Good morning, everyone. Today I'll be speaking about the scheduling algorithms and giving an explanation on them and giving some program. Introduction to scheduling algorithms. Scheduling algorithms are nothing but algorithms which are used to ensure a efficient allocation of the resources and managing the various tasks in the system. They play a crucial role in optimizing the resources, improving performance, and meeting deadlines by the real-time systems. That is, they play a major role in ensuring the distribution of the proper resources to the proper tasks, which in turn leads to the improvement of the performance. And this improvement of the performance is very helpful for the real-time systems. Different scheduling algorithms have different objectives and have different ways of performing the required task, but they all mainly contribute towards maximizing the throughput, minimizing the response time, and improving the performance. First, we'll be talking about the first come first served scheduling algorithm. As the name suggests, here the task that comes first will be served the resources first. Here there is no preemption, as one task that comes in will be executed on until the completion of that task. Uh, so here the task that comes first will be executed first, and later the tasks that comes next will wait until the execution of the current task, and after this task is completed, then only the algorithm will move on to the next task. This can also be a problem in this algorithm because this thing leads to an effect called convoy effect. Here let us consider a task that requires a very long time to be executed. Then the tasks that come next to that task will have to wait until this task gets executed. Here this doesn't ensure fairness, as the tasks that come next will have to wait for a longer time if the task that is currently being executed has a longer execution time. Next, we'll be talking about the shortest job next scheduling algorithm. Here the this is a preemptive algorithm. That is, there is a repetition of execution of the same tasks again and again. It maximizes, it compares the waiting time between uh, average execution time between two different tasks, and the task having a less execution time will be given the higher priority. Let's take a task that comes first, having a execution time of 10 milliseconds, and let's consider another task which has a lesser execution time. The first task will be getting executed, and when the next task that comes, let's take the first task having 10 milliseconds, and the next task that comes to having a completion time of 2 milliseconds, then the task having the shortest time will be given the priority. Here the second task will be executed first, and then the first task will continue its execution until the task completion. Next, we'll be talking about the round robin algorithm. Round robin algorithm is also a preemptive scheduling algorithm, but the different here is it will be having a fixed time slice called as the quantum. This quantum is nothing but the amount of time a single task is given for each cycle, and like let's take a task which is being executed for now, and that task will be executed for the quantum time, and the task that comes next will be compared with the present task, and if that task has a lesser burst time, then that task will be considered and it will be executed for the quantum. Again, the next task will be checked for whether it is having the lesser burst time or not. If not, the current task will be executed again for the quantum, or the next if yes, then the next task will be considered given the priority and will be executed for the quantum. Like this, the tasks will be executed for the quantum and compared constantly until every task's burst time or completion time is satisfied. However, due to this, the round robin algorithm suffers from a higher overhead because there will be a high looping between these tasks, as there will be constant switching between the tasks, and this is not suitable for the real time system, as the overhead will be high. Next, we are talking about the priority scheduling algorithm. Priority scheduling algorithm is nothing but in this algorithm, each task will be assigned a priority, and the task having the highest priority will be executed first, and the task having the lower priority will be executed last. In this, the problem we face is the low starvation that might be faced by the tasks having the lower priority. Let us consider a task having the higher priority, which requires a large amount of time and large amount of resources. The task will be started to execute. As the task get executed and the resource being consumed, the if what if the resources are not enough for the low priority task, then this leads to the starvation of the lower priority tasks, and they might not get a chance to get executed, as they will be waiting to be fulfilled the needs of for their resource needs. And the this is the problem faced in the priority scheduling algorithm, and it's only faced by the task having the lower priority. Shortest remaining time scheduling algorithm. It is a preemptive algorithm that is a variant of the shortest job next algorithm. Here, the selection of the task is done through the task that is having shortest remaining execution time. That is the task that is having less execution time remaining will be taken as the next task to be executed. It dynamically adjusts priorities based on the remaining time, ensuring the shortest tasks are prioritized. It constantly changes the priority based on the tasks having lesser remaining time, so that the task having that the shorter tasks get prioritized more. Shortest remaining time can provide optimal performance, but requires monitoring and frequent context switches. That it is nothing but it can provide an optimal position, but the main requirement is the shortest remaining time algorithm is that there will be a it needs a continuous requirement of monitoring, as there needs to be a complete checking between the remaining times of different tasks, and there will be frequent switches, because there will be a switching between the task on the amount of uh, remaining time. Multi-level queue scheduling algorithm. Multi-level queue scheduling algorithm is nothing but it divides all the tasks into priority levels and queues, like tasks into different priority levels and into different queues. Here, each each queue or each priority level may have its own algorithm. That is, let's take a series of tasks which will be divided into three different priority levels or queues. Here, one queue can take the round robin algorithm, one can take the first come first serve algorithm, and the next can take the shortest job next algorithm to execute. Multi-leveling queue scheduling provides flexibility and efficiency in managing tasks with various priorities and characteristics. Here, what we have is the option of considering the tasks with different characteristics and dividing them on basis of that, and we can provide a very optimal algorithm for each queue, so that the overall performance is increased by a lot, because we are providing the required algorithm for with the required characteristic for that particular queue, or for that particular type of queue, which increases the efficiency of the algorithm, overall increasing the efficiency of the system. Here is a program on first come first serve in the programming language of Python. Here, we have a function for first come first serve, which takes the tasks as the input. Completion times is nothing but a list of time taken for the completion of each task. Current time is nothing but the time for a particular task. Now we have a loop here, for loop here, which checks the time for each tasks in the list of tasks. Now we have current job plus equals to task burst time. So here, the current time will be added increased by the total burst time of the each task. And completion time dot append current time, in this line we append the current time of the task to the completion times list. return completion time, the date of the completion time will be returned. Here the current time will be added according to the total time taken to execute for all the tasks, and the completion time will be taken according to the total time taken to execute each task and will be added to the list accordingly. Now we have a Python program for the round robin scheduling algorithm. Round robin scheduling algorithm is here we have two things, that is the tasks and the quantum. Completion time is taken as an empty list and the remaining time is taken as the remaining time after the taken a burst time. That is, one burst time is given and the amount of the quantum is executed within the burst time, and the remaining time will be taken out of the burst time here, and the current time will be considered as zero. While the total amount of sum is less than the remaining time, is greater than the remaining time, total amount of sum of the remaining time is greater than zero, that is the amount of remaining time is not equal to zero, the task still needs to get executed. Then for I, tasks in enumeration of tasks, like for the task having the highest priority in the tasks, in the list of tasks, if remaining time of that particular task is also greater than zero, then that amount of that task will be executed for the amount of the given quantum, and this whole loop will be repeating in and itself until all the tasks will be satisfied, and until all the tasks are completed, task completion occurs. Conclusion, algorithms, scheduling algorithms are nothing but algorithms that are basically used to enhance the performance of the real-time systems by reducing the response time and increasing the throughput of the systems. And different kinds of scheduling algorithms can be implemented for different instances and for different various requirements and characteristics, just for the mainly for the purpose of increasing the performance, overall performance of the system. Thank you.